Hello, everyone. Thank you so much for joining our webinar. It's called Building Enterprise-Grade RAG with AWS Agents and SingleStore. Thanks so much for our speakers for joining today. We have Victor Rojo, who's a Principal Tech Leader at AWS Generative AI I'm so sorry, I'm not able to see that. Very sorry about it. I'll leave it to you, Victor. So thank you so much for joining. And Alex, he's a growth engineer here at SingleStore, is also a very regular speaker at our webinars. So thanks so much for joining, everyone. Thanks to the speakers for taking out the time and speaking for this session. And we'll just wait for a few more folks to join in, and then we'll start. So I'll be your moderator for today. I'm Yukti, and one of my main jobs here at SingleStore is to organize these weekly AI webinars. We organize maybe 2 or maybe 3 webinars per week and demonstrate different data and AI use cases. We also post about our upcoming webinars here and now. So if any of these topics are interesting to you, feel free to connect with me on LinkedIn or maybe follow SingleStore to stay on top of the loop. I'll also like to hear your feedback or ideas on topics that you would like to see in the future sessions. So please feel free to connect with me or drop a message on LinkedIn. Speaking of future sessions, we are actually presenting tomorrow. And I believe, Alex, it's a webinar with you, right? So it's called Deploying AI-Driven Personalization Engines. And on October 24th, we have a partner webinar again, Building Secure, Scalable Data Access APIs with Hasura and SingleStore. So if any of these topics are interesting, RSVP right now. And I hope to see you all there. I'll be putting links to everything in the chat. So coming back to today's topic, you're welcome to participate in the discussion throughout the session using the Zoom Q&A button, which is present at the bottom of your console. Please know that you are in a listen-only mode and the chat is disabled for you guys, and you're not allowed to exactly raise hand. Like, we take questions using the Q&A button. We have an internal mission statement to try to answer 100% of the audience questions. Just make sure that you have logged into Zoom with your name and email address, because we will not be taking up any anonymous questions. I would like to announce that we are also doing a raffle during today's webinar. So anyone who tries out SingleStore during this webinar will be entered for a chance to win either branded new AirPods Pro or Meta's new Ray-Ban LLM smart glasses. Simply click the link that I will be providing in the chat and log in. You may know that SingleStore has had a free trial offer for many years, but just in the past few days, we have also announced a new pre-share tier. So it's absolutely up to you. If you want to have a hands-on experience, please feel free to just go through everything during the webinar. I'll be posting all the resources, and we will also send a follow-up emails with the relevant stuff that's included in today's webinar. That's it from my side. Victor, please take it away. And thanks again for joining.
All right, and thanks for the invitation and for having me here.
Very happy to have you.
Perfect. Thank you. Thank you so much. Maybe introductions are already there. I'm gonna kickstart with the agenda for this webinar, for this session. I want to introduce and kickstart with the generative AI stack to talk a little bit about what we are doing in the generative AI space as AWS. As previously mentioned, I'm working as the tech leader for the generative AI competency partners. SingleStore is one of those partners that already applied, and it's part of this program that brings to the customers experience, expertise, and success. This is basically the 3 basic questions that or aspects that I always highlight about the partners in this competency. And it's already related to the generative stack, because AWS tries to bring different options through different audiences and personas. I will be talking about that. Next, going a little bit deeper into the topic about agents. As you know, part of the future of Gen AI is agents, multimodal, agentic solutions and applications. So I will be providing some details about Amazon Bedrock agents. Then I will also introduce and try to connect this topic with data. Data is one of the most important things that bring the value to your applications. An application using just generic large language model / foundation models, it's okay. But when you introduce your data at different levels of patterns or customization that I will also introduce how we see that AWS, that will make a difference. And that's totally related to SingleStore, where today we will find out how we will understand what is SingleStore. We will get an overview from Alex. We will also witness a demo that he will be doing. And finally, we will jump to a Q&A. Please submit your questions. And also, we will talk about a call to action, next steps that we can be doing after this session and webinar. So let's get started, and thanks for being here. So we are when are we getting ready to building and to build it in build generative applications in a secure, responsible, and fast way using AWS. In AWS, we continue to reinvent for our customers. We've learned that what they need to bring generative AI to their customers, to their employees, and also the capabilities to build inside those applications. And if we see this from a bottom to top or a bottom down to top point of view or aspect, we can see that at the bottom, we can see performant and cost-effective infrastructure through different solutions based on GPUs, based on the services known as training and inferential that are totally oriented to the model training and serving. SageMaker, that platform that helps you to train your models, to develop foundation models, to customize models from an end-to-end perspective that includes tools for those specific aspects of the process. There are other solutions that you can see in this part of infrastructure, but basically the message is we have the computer performant services plus the platform to train, to customize, and to serve your models. Of course, we need a secure, a private, an easy way to build and scale applications with foundation models. And this is in the middle tier where you can see Amazon Bedrock. Amazon Bedrock is like the start in very commonly in the space of generative AI with AWS. It has several options of models. It brings options of multiple models with multiple capabilities, each one of them. Models from industry leaders that you maybe already are aware of. For example, Mistral, for example, Anthropic, other models from AI21 or Cohere. And we are also bringing our models from the Titan models for text generation, for embeddings, multimodal embeddings, and more capabilities. And finally, you need also for those personas that are more focused on building applications without necessarily being experts at software development or data science. What we are bringing to the table is a generative AI-powered assistant that helps accelerate that creation of applications, leveraging the company or your organization's internal data without exposing it to others. And this is where Amazon Q, it's the main rock star or the main star or in the top tier that you can see here. And this is all AWS built with our high bar for giving you broad and deep capabilities, choice, and enterprise readiness. With these tools available to start building, it can bring us to, and let's talk about Amazon Bedrock Agents. Amazon Bedrock Agents, it's part of Amazon Bedrock. And we've seen that the foundation models are great for having conversations or generating content. But of course, we want them to make more than just generating content. This has been, I remember, almost 1.5 years or 2 years that I started to experiment a little bit with agents using LangChain at that time, because I wanted to get them to take more action, to do more, like, for example, solving problems, using tools, discover information, interact with systems, using APIs. And examples of these interactions could be, and processes could be, for example, booking a flight seat, for example, or filing and processing insurance claims, or, for example, ordering replacement parts. It's examples of those different processes that an agent could help us with. Amazon Bedrock also helps, and the agents help to plan and execute multi-step tasks using company systems and data sources that could go from answering customer questions about product availability to taking their orders. For example, it's what we can do, or what agents can be capable of doing. With Amazon Bedrock, it's easy to create agents. You can create it in just a few clicks by selecting the foundation model, providing access to different systems and knowledge bases, and maybe you will need a few AWS Lambda functions, and that's it. That's what you can do. The agent analyzes the user request, automatically calls the necessary APIs and data sources to fulfill that request, based, of course, in what you provided, contextually speaking about the data, the access, and the tools, and the Lambda functions. Um, all of this happens in a secure and private workspace. There's no need to engineer prompts to manage session context or manually connect to systems. Also, the agents for Amazon Bedrock gives you visibility into the foundation model's chain of thought reasoning. You can use the trace, the COT, trace from Amazon Bedrock to troubleshoot responses and modify the instructions for better responses, for fine-tuning, basically speaking. You can also modify the prompt generated by the agents for Bedrock and steer the foundation model towards the desired behavior for a better user experience. Some aspects that I wanted to share that agents cover. For example, we are talking about code interpretation. This allows the agents to generate and execute code, to perform certain analysis or generating charts, or also processing input files with different data types and formats. For example, CSV, JSON, PDFs, TXT, HTML. The code interpretation allows to uh, not only generate charts, but also in general helps to enhance the user experience and making their interpretation more accessible. Another aspect that is important, and it's a hot topic since I was in the conversational AI competency and talking about chatbots creation, it's memory retention for agents. The idea of um, getting agents, at that time it was chatbots only, or Alexa. It was, my origins come from Alexa in Mexico. Uh, Memory helps the agents to learn and adapt to its users' unique needs. This also leads to personalization, because you can, with that memory retention, understand the preferences over the time, to understand the needs, what is mostly related to a better user experience. Also, by maintaining this persistent memory, the agents can pick up right where the user left off, providing, for example, a smooth flow of conversation and workflows, especially for complex multi-step tasks, or think about those, let's say, long time running processes that maybe at some point we might need in the applications that we are developing. And there are more features, and this is more like an announcement from Amazon Bedrock. It's faster and easier to use. Now integrates with Claude 3.5, 3.5, with Sonnet, with Haiku. It requires less steps to create an agent. The schemas are simplified, now enable faster schema creation, and there's no need to conform to the Open API specification. It was something I at some point was raising my hand. Hey, we don't need to do all the time Open API specifications. Stick to that, but it's a good practice also that the Bedrock team was trying to implement. Return of control also, after a agent finishes, the return of control allows business logic implementations to continue certain additional steps, maybe after the agent's execution. And now I want to highlight the importance of building Gen AI at certain level. It's good, but when you want to build generative AI applications that are unique to your business needs, there is your differentiator. When you think about it, every company has access to the same foundational models. Everybody, even individually, we get access to those models. But to be successful, to get a better customer experience, to build next level applications with real business value, uh, those ones that achieve that are those that are using their own data. The data makes the difference between generative AI applications and those that know your business and your customers deeply. We are seeing very creative generative AI users, including intelligent conversational chatbots, uh, code generation from text and summarization from different documents such as books, narrative, and transcripts, for example. And we are also seeing a trend of popular application building patterns that AWS customers are using to build generative applications. And let me show you how these patterns are and how they leverage your own data. These patterns or techniques for optimizing generative AI outputs with your own data are important because you will need to identify which one is right for you and your use case. This is not fixed. You can select what is enough, what is the next level that you can achieve to provide better outputs using your own data. These techniques are Retrieval-Augmented Generation, RAG, fine-tuning, and continued pre-training. All of these ones are commonly ranked by their level of complexity. And these three techniques are supported by Amazon Bedrock. The cheapest and easiest place to start is using your data to customize the outputs of an existing model using Retrieval-Augmented Generation. With this technique, there's no need to retrain a model. You are doing model augmentation, and this external data that you are using augment your prompt so that you can come from multiple data sources, including repositories, databases, APIs, and helps the models to adjust its outputs with the data retrieved as needed from the knowledge libraries that we are connecting it to. The next level is fine-tuning. When you fine-tune this specific foundation model, you are using a smaller sample from your own domain-specific data. And basically, you are creating a new model with your prepared data set that you created previously. And finally, the continued pre-training means basically that you pick up where the foundation model provider left off. You are training the model on data sets in your enterprise to extend both the generalized knowledge the model has and the specialized knowledge that you are bringing to this model. These types of customizations are accessible through Bedrock, as I mentioned before. And the Amazon Bedrock allows you to customize model responses to using your own data and to bring next level generative AI applications. And let's jump to SingleStore with Alex to get an overview and a demo that he prepared already. Alex, it's your turn.
Great. Thanks, Victor, for the amazing overview of what AWS is doing for Gen AI. I mean, I've personally been playing around a lot with Amazon Bedrock agents, and yeah, no, you set a high bar. It's gonna be hard to clear with some of the information that I've got prepared here. But let's see. I'm gonna share my screen here. Oh, Victor, I think you have to stop sharing before I can share. See. Great. Let me share. Oh, Victor, I think you're still sharing. Okay, there we go.
Okay, you can
Right.
share now. You have the control.
Awesome. Thank you. Thank you. Okay. Let's see. Okay. Great. All right. Hopefully everyone can see my screen. Great. So today I just wanted to talk a bit about and expand more on what Victor has already kind of explained about RAG, specifically where we're seeing differences between naive RAG and enterprise RAG, and really a lot of the requirements that we're seeing pop up around enterprise RAG. And then I want to talk about this really new paradigm that we're seeing around RAG called multi-agent RAG, and this kind of emerging architecture that's becoming increasingly popular because it solves a lot of the issues that we're seeing with naive RAG. And just to give kind of like a foundation for everyone who's not familiar with what RAG is essentially it's acronym for Retrieval-Augmented Generation. And it's essentially the way by which we infuse an LLM's knowledge or context window with information that it wasn't trained on. So this is essentially all information that is private to your company, your enterprise, to your personal life. It's most likely that an LLM was not trained on that data in any significant way. And so, traditionally, if you talk to an LLM about, say, for example, last quarter's financial report, it's not going to know anything about your specific circumstances, your specific company, and it's going to hallucinate. It's going to kind of make figures up. It's going to make facts up. I'm sure many of you that have interacted with LLMs before have seen this kind of phenomenon. And so that leads into, the kind of version 1 of RAG that we've seen pop up to solve this issue, whereby an application talks to an LLM, and then it also talks to a vector database, so something like Mongo or Dynamo, and then that vector database is fed with vectorizations of unstructured data, like your PDFs, like your audio, your video, and all of that kind of happens in what we at SingleStore see as like a single thread. It's not quite yet multi-threaded. Kind of in parallel, we see, with the evolution of the web, we've seen, a shift from a monolithic architecture, right, where you kind of have a front end and a back end sitting on top of a database, to a much more modular architecture, where, or rather, a microservices-based architecture, where a front end talks to an API gateway, and then that API gateway routes requests to various services that are responsible for specific inputs and outputs, right? Maybe for an e-commerce website, you would have a user service, a product service, an order service, and these all talk to their own databases. They all kind of have their own actions that they can take. But largely these processes, this kind of microservices-based architecture, largely these are deterministic. They're kind of set in how they run based on what the user or the end user requires from the system. And we're really seeing this paradigm sort of map onto everything that we're seeing with RAG, right? Like we talked about before, traditionally naive RAG has this linear structure whereby data is loaded into a vector database, which then is fed into an LLM, an LLM's context window via kind of semantic retrieval. And then from the LLM, the tokens are fed into the front end and finally presented to the end user. And I realize I'm using some jargon here, so please feel free to use the Q&A function. I realized I was looking at the Q&A a little earlier and already getting a lot of great questions. We will cover some of those questions actually later. So just a quick aside there. But back to this single-threaded RAG architecture that we've been seeing thus far. The pros of it are that it's very easy to set up. It's very easy to set up, a proof of concept, show off a cool demo, but to move to production requires a whole set of different requirements and headaches that a single-threaded architecture is just not prepared for. And what we've seen with the microservices-based architecture for the web, we're really seeing coming into the RAG architecture for LLMs in the form of agents. And so Victor already talked a bit about agents, what AWS is doing for agents, but hopefully, this explanation gives some motivation for why we're seeing a lot of this hype, honestly, about agents and well-deserved hype. And the reason for that is agents allow for your RAG architecture to parallelize. It allows different component pieces of the architecture to be individually testable and kind of individually verifiable in terms of inputs and outputs, and individually run on different threads, right, asynchronously, so that you can handle many thousands or hundreds of thousands of concurrent users, so that you can handle failures in any single part of the system, so that for from 0 to 1 million users, you have a consistent experience that is necessary for production that you may not require for just a very simple proof of concept RAG app, right? And just kind of on the right here, we have the kind of archetypical example of an agent-based architecture for RAG, where you have an embedding agent, you have a documents understanding agent, a research agent that does maybe further research on the documents. All of this feeds into a supervisor agent, right? Which then kind of collates this information, stores it so that you're later able to access it as a user. And this is just an example architecture. We're really seeing a diverse array of potential architectures, a diverse array of best practices, because this is such an emerging space. So really keep an eye on this space and really stay tuned, because there's a lot of really great building happening here. Great. We've talked a bit about agents, and we kind of understand the motivation for why agent-based architectures are interesting, why they might be useful for a production application. But what actually lies inside of an agent? Victor touched a bit on this, and I want to expand on this a little more. What we really see as 3 core pieces to an agent are: 1, the intelligence. And so that's your LLM. That's the underlying foundation model. 2, it's your data, the knowledge that the agent has access to, right? If you miss the data piece, you're going to have a lot of hallucinations. Or if the data piece is faulty, or if the RAG architecture isn't returning the relevant document, you'll also get hallucination. So intelligence and knowledge together create the kind of the RAG kind of LLM, the RAG-enabled LLM as we've known it so far. But what really makes an agent is access to tools. And programmatically, these are APIs, application programming interfaces, as I'm sure many of you are aware of. Tools allow the LLM to not just sit passively on your website, for example, as a customer support bot that sits there and takes questions from users, but it actually allows the LLM, combined with its knowledge, to affect change for business outcomes. Like, for example, placing an order for a customer, giving a customer a refund, diagnosing a customer's issue by interfacing with some external system, right? And we'll actually see a really cool example of how this all comes together at the end. So stay tuned for that. When you have all of these agents together, right, you don't just have one agent necessarily that does everything, but you have many individual agents that perform specific tasks. Then you get a multi-agent RAG system, right? And just as an example here, I'm not going to dive into all of the kind of the nitty-gritty details of this slide here, though I'm happy to share more in Q&A. You might have an agent that provides guardrails for your chat. So this agent looks at every new chat message, it refers it against your existing company policies, and then it determines if this is a safe message to return to the user or not. You might also have a retriever agent, right? Again, going back to that RAG piece that we were talking about earlier. This retriever agent might be focused on more unstructured data. So PDFs, audio, video, images, right? Data that traditionally you have to vectorize, right? Using an embedding function or embedding model in order to perform semantic search over, right? And again, jargon, happy to expand on it in the Q&A. You might also have a structured agent or structured retriever agent, sorry, that hits a relational database, right? The kind of database that you query using a database like SingleStore that you query using SQL in order to access, say, for example, information about a customer's order, like the time that it was placed or the price that was paid for it or any discounts applied to it. All of these are, deterministic pieces of information that fit nicely inside of a structured database, but that might not necessarily, or actually will be retrieved more poorly from a semantic retriever. And happy to dive into more of these details here. And I'm going to kind of skip over the rest of that for the sake of time. And now I want to touch a bit about kind of more advanced techniques for RAG that we're seeing kind of in the early innings of multi-agent RAG, we're seeing perform really well for moving concepts or proof of concepts to production. And so just to kind of give a broad level overview of some of these techniques, the first that we're really seeing be useful is input-output validation, right? That's going to be similar to the guardrails agent that you saw on the last slide, where you are, as an enterprise, you're really concerned about making sure that, your agent is not going off and spewing, unfactual, unsupported information, right, about, potentially your own product, the competitor's product. And so that's a really huge piece that we're seeing unlock agents for actual enterprise use cases where we're seeing much more reliability for input-output validation by using these multi-agent architectures. Another big piece is evals. For those that have attended previous webinars before, I've really been harping on this piece of just RAG in general. Evals, whereby you evaluate or where you first save responses from your chatbots, and you have some process by which you allow customers or end users to evaluate the usefulness of that response, by clicking a thumbs up or a thumbs down, or by, maybe ranking scale of 1 to 5, how useful that information was for them. Each individual data point may seem like, oh, it's not that big of a deal. It's just, this is maybe a more useful response. This is a less useful response. But the reason that evals are so key is twofold. One, evals are the way that you actually create a moat around your company's Gen AI solution, right? Everyone has access to the same foundation models. You can apply for access to, a model from Anthropic, from OpenAI, and immediately get access to, honestly mind-boggling, Gen AI and LLM intelligence, right? What not everyone has access to is, one, your private company data, and then two, conversations with your private company data between your internal users, your external end users, and the chatbot, right? And then on top of that, a ranking of how useful those responses are provides and creates a data set that becomes honestly like data gold or data oil to create a fine-tuned foundation model for your own company, for your own use cases, right? That no one else is able to touch because it's based on both information from your private users that they're providing, feedback that they're giving about their responses, and it's based on your private company data. So few of these pieces: evals, re-ranking, caching, guardrails, hybrid search, especially this hybrid search piece where you combine unstructured and structured data. We'll touch on that in a little bit. These we're really seeing unlock, proof of concept, kind of naive RAG applications, and transforming them into multi-agent, enterprise-grade GenAI solution. So we've learned, all of this, all these concepts about naive RAG, enterprise RAG, multi-agent RAG architecture, what makes up an agent. We've learned about the importance of the data layer for agents, right? But what actual requirements should we be expecting of the data layer for our agents? We believe this is a threefold answer, right? First, accuracy, that your responses should be grounded in data with explainability. This kind of touches back to the guardrails piece. Second, relevancy, right? You should be able to return relevant results, right? And not just relevant results, but these results should be tailored to you, right? If you are an end user, an internal user that only has access to specific rows, or should only have access to specific rows, then the LLM should not be going and searching over a bunch of information that you are not supposed to have access to, because that's a liability concern. And then third, and this is where we believe the unlock truly happens for real-time multi-agent RAG, is latency, right? Traditional vector databases require the creation of indices and can really bog down when you go from just one or two PDFs to, say, 100,000, a million, right? And you go from hundreds of megabytes to hundreds of terabytes to petabytes of data, right? When your end user is sitting on a chat screen or performing an action with an agent, and they have to wait 5, 10, 15 seconds for results to be returned to them, that's a proof of concept experience and not an enterprise experience. So latency is the third big piece. And so all of this combines together to create what we call the enterprise RAG stack. And this is the way this is really what SingleStore kind of excels at, by combining unstructured data, document JSON data, data from data lake houses and warehouses like Iceberg data, as well as your SQL data, by combining that all into a single database that is able to ingest, hundreds of terabytes per second, that is able to, query on real-time, fast landing data in hundreds of milliseconds and not hundreds of seconds. You get a data stack that is able to kind of perform to the requirements and the SLAs of even the most hardened enterprise kind of workflows out there. So that's what SingleStore is: transactions, analytics, and vectors at petabyte scale in milliseconds. And just to give some color on how the core engine works, at the kind of core of SingleStore is our columnar store, our universal storage, that allows us to perform analytical queries at millisecond latency on petabytes of data. We also have a row store for more transactional focused workflows, although our columnar store is fast approaching our row store in terms of transaction performance, and already allows for real-time ingest, hundreds of thousands of writes per second. And then again, that hybrid search piece, allowing you to store all of your data, your JSON data, your vector data, your SQL data in one database, and simplifying your data architecture across the board. Great. So Now I want to move to our demo. I realize that we are at 10:40, and I'm sure we have many, many questions. Great questions coming in so far. We will have a bit of time, I believe 10 minutes at the end for questions. But now I want to kind of give a brief overview of the demo that we're going to be doing. What we're going to be doing is first, we're going to be going into SingleStore. We're going to be creating a free shared tier workspace. Following that, we're going to learn about how to actually create an Amazon S3 bucket and to pipeline that data into SingleStore for real-time ingest. And then finally, we're going to create our first AWS Bedrock agent with an Amazon S3 bucket as our knowledge source, which is continuously feeding its data into SingleStore, allowing for real-time analytics on top of your knowledge base. And as your agent writes to that knowledge base, as it updates its memory, you're going to get real-time analytics across all of that. And then finally, following all of that, having learned how to set everything up from 0 to 1 for an AWS Bedrock agent, we're going to see really what's possible with SingleStore and AWS Bedrock agents via, I think, a really cool demo that we built out together with AWS. So great. First, let's go ahead here. And I want everyone to go, or if you want to sign up for a SingleStore free shared tier workspace, you can go to this URL right here, singlestore.com/cloud trial. That'll bring you to this page. And you can just go through, CAPTCHA. Maybe I'm in LLM. It might think that. We're just. Oh my goodness. Wow, this is one of the longest CAPTCHAs that I've ever done. Okay, great. Not a robot. Amazing. So once you're in SingleStore, you'll want to go to deployments. And then you will want to, you will want to go to deployments. And then you will actually want to, you want to go ahead and, here, I will terminate this workspace really quickly, so we can show the workspace creation. Make this one as well. One second here. Great. So, sorry, just showing this on a new account so that we don't have to terminate a bunch of workspaces. Once you're inside of SingleStore, you want to go to deployments. I'm going to click Create Workspace. And then inside of this setup page, you're going to want to create your first workspace. You can create, let's see, you can choose your kind of preferred cloud provider here. We're going to choose AWS. And then you can kind of select your workspace details here. And you do get, I believe, $600 of free credits. And you can also switch to a free shared tier, free forever shared tier workspace. But we're just going to go ahead and create this workspace here. We are actually not going to go, well, while we're waiting for this workspace to deploy, we're actually going to go ahead and start taking a look at how to load data from AWS S3 into SingleStore using one of, I believe, is the coolest SingleStore features, pipelines. And I believe the code for this is shared out in the chat. So I'm just going to kind of go over the broad contours of how this happens for the sake of time. But essentially what you're going to do is you're going to create an AWS S3 bucket. and that's going to happen inside the AWS console. We're going to go into the console in just a second. After saving all of your credentials, you're going to create the database first inside of SingleStore. So after your workspace deploys, you will create a database, connect it to your workspace, and then you'll actually run inside of Data Studio this create pipeline command, where you set the AWS S3 URL, you set the config details, your credentials, and then you are able to actually pipe all the data from your S3 bucket directly into SingleStore in real time. Great. And I know we're moving a bit quickly here, so just want to give everyone a quick reminder that this is a recorded session, and you can refer back to this webinar later on to kind of go back over the steps here. But once you've created your S3 buckets, inside of the AWS console, you'll want to go to Bedrock. And we are actually already there, but I just wanted to show everyone how that happens. From Bedrock, a few things need to happen. You actually will need to, if this is your first time using it, you'll need to request access to foundation models. So from the AWS partner foundation models providers, or from the existing AWS foundation models, you'll need to request access. And once you do have access to those foundation models, you'll want to go inside of Builder Tools, and then you'll want to go to Knowledge Bases. And here you'll actually create a knowledge base with the S3 buckets that you've created. And you'll actually select the alias for the S3 buckets. We'll just kind of go with the defaults here. And obviously you're going to customize all of this for your specific use cases. But once you have gone through this step in the knowledge base creation, you're going to want to actually attach your S3 bucket that you're piping into SingleStore. And then you're going to select your embedding model. And here, I'm just going to select Titan Text Embeddings v2. It's one of Amazon's embedding models. It's a great general purpose embedding model. If you're curious about the choice of embedding model, we have some webinars on how to fine tune your embedding model, as well as there's some details there about what decisions you should be making around choosing an embedding model if you're more interested in that. But yes, once you've selected all of these details, you're going to go ahead and create a knowledge base. I'm going to hold off on that for now as we move into the actual agent creation tool. But once you have your knowledge base created, you're going to create your first agent under Builder Tools in Agents. And here there's a lot of details to cover here. So I'm just, again, going to go over the broad contours of it, and I'll go over, and please do ask questions that you're interested in the Q&A. You're going to have a number of different kind of steps to consider here for your specific use case, for your specific, workflows. Obviously, your agent name, your agent description. You'll want to also provide instructions for the agent, right? And there will be a temptation here for many of us, I know there was for me, to kind of try to create an all-in-one agent, like an agent that can, like a Superman type agent that can do everything. And that works up until a certain scale. But what you'll quickly find as you move into production is that agents with many tools, with access to many tools and a large instruction set, will tend to actually perform worse than a well-orchestrated cluster of agents with well-defined roles and tasks and responsibilities, much like a human organization. People with well-defined roles and tasks responsibilities that are in a well-orchestrated organization tend to perform much better than someone that is a jack of all trades, right? So that's where your instructions for your agent, that's where you're going to be thinking about what the agent's actually going to be doing. Here, you're going to add action groups. And again, a bit too much detail to get into just for the scope of this webinar, but action groups are where you will actually provide API schemas for your agent to be able to interact with external services, to interact with your internal company tools. And these will come in the form of AWS Lambda functions or open API compatible JSON schema files that provide an API path as well as a description of what this API takes as an input and an output, so that your agents are able to reason about what these tools are able to do. But once you've defined all of these, and these are quite challenging to define, and you will have to kind of continually iterate on defining your instructions and your action groups, you can add your knowledge base, and this is where you'll select the knowledge base that you've created and that you're typing into SingleStore. And then you can, on the right-hand side here, you can begin to test your agents, right? You can chat with it. You can ask it for, you can ask them certain issues. And actually, we're going to see a really quick demo here of how that actually all comes together. So I'm going to go ahead and play this video here. See. Oh, actually, Victor, really quick ask here. I believe I cannot share audio through my computer. Do you have access to this video link? And do you think you could play it?
Let me see if I can get access to it. Looking for it. Give me 1 second.
Sure, thanks. And I will go into the Q&A here while we're waiting and just see if we can answer some quick
I just tried to
questions.
update some settings. Just maybe try playing it once, and if the audio plays, that's okay.
Okay, I can try it, but I believe I think it said on my computer that the audio sharing was not enabled. But let me give it a shot.
Let me try.
Can you hear it?
On my side, I will.
Oh, can you hear it?
No.
No.
Yeah. Sorry about that. There's always
try from my
always
side.
technical difficulties in live demos, but let's take a look at some questions here. So we got a question from Shyam who asked, embedding model and foundation model are the embedding model and foundation model the same, or can we use them interchangeably? That's actually a really good question. They are not. The embedding model is the model that vectorizes your unstructured data, so your PDFs, your audio, your video, your images, and transforms them into a format that you are able to perform a semantic similarity search over, which once retrieved, that information is then put into your LLM context window. That's your foundation model context window, which actually does, what you traditionally know as LLM inference, like chatting with ChatGPT. Great.
Can you hear my audio?
Let me stop sharing really quickly, actually.
Do you hear my audio so far?
No. Do you want to try sharing the video? I can also, let me try. What we could do is could we share out the video link with the attendees and then just kind of answer a few questions?
Actually, yeah, I would also advise that. Just we
Yeah,
have a
just
lot
because.
of questions, and I can, send this video out like in the follow-up emails, and like everyone can refer to that.
Okay.
Okay,
Okay.
great,
Sounds good.
great.
Yeah.
All right. So let's see. We got a question from John Gemily who asks, RAG seems to replace retraining models on personal data. Yes. So I believe this refers to how RAG can sometimes be a replacement for fine-tuning a model or a foundation model on your personal data. And there's a few important nuances to kind of pick out here. The biggest being that RAG and fine-tuning, they perform similar functions, but actually serve different purposes. RAG you can think of as a student at test time having access to the textbook to be able to perform on the test with better performance, right? Fine tuning, on the other hand, is like a student going into the textbook in the weeks, the days, maybe the hours if you're like me before the test, and actually trying to learn the material so that the um, material is kind of embedded in your brain, in your kind of intelligence, and so that when you actually go to the test, you have not necessarily the exact facts and knowledge, but the skills and behaviors necessary to perform the task at hand. So that's sort of the big dividing line between RAG and fine tuning. Victor, did you see any questions that you wanted to kind of call out or answer here?
Yeah, I saw a couple of questions that I answered. It was related to um, difference between fine tuning and continued fine tuning of LLMs. Everybody in the context of AWS, fine tuning is provide label data in order to train the model to improve performance and specific tasks, and continued pre-training is provide unlabeled data to pre-train a foundation model. I shared a link to uh, uh, the person who asked about this. Another one was related to the lack of authentication. Without authentication, whether we can retrieve data from database, how can RAG work based on authentication authorization? I shared a link in the context of AWS, how you can implement different measures and security measures for access controls, different anti-patterns for security that not only consider database authentications, but other areas in your generative AI application. Okay, there's another question. RAG seems to replace, this answered already.
I did see one question about from Raghuram about
Relationship.
whether different agents share memory or context window among each other. And I think that's actually a really great question. Not by default, but if you give agents the same knowledge base and they're reading and writing to the same database, then they are able to share the same memory and context in the sense that they are pulling using semantic search from the same corpus of documents, right? And sometimes you might want that for an enterprise use case. Sometimes you would like separation of document corpuses so that you don't mix up so you don't mix up documents and return them to return internal documents to end users or personal information to other end users. And I think we maybe have time for one more question. Victor, do you want to pick out one last question to kind of answer here? I know that we are at the top of the hour.
Yes, there was one person asking about relation between monolithic and RAG agents. They are saying it's not quite clear. They are trying to solve what we are trying to solve in monolithic architecture using RAG. Could you go over that, please?
Sure, yeah. So just to give, again, the motivation for why we're seeing a lot of enterprises move to multi-agent RAG architectures as opposed to staying within single-threaded RAG is the ability to parallelize the different functions of a RAG stack, right? So, if you're just working with, say, for example, 5, 10, maybe even 100 PDFs and structured data on top of that, maybe it works to kind of haphazardly put together, a document database and a relational database and a vector database. And that, kind of works well enough for a proof of concept. But as you move into production and you're, ingesting hundreds, thousands, maybe even, tens of thousands of documents every minute, individual pieces, one, the staying single threaded is just not an option because you're going to be blocking the ingestion of other documents as existing documents are waiting to be put into the database, to be vectorized, to be tagged for filtering, right? That's kind of blocker number one. And if you parallelize and you move to a multi-agent RAG, you're able to allow for ingestion and retrieval to happen asynchronously with non-blocking operations, which allow for true unlimited scale as well as verifiability of the individual pieces of the system to allow for testing of individual expected inputs and outputs of each part of the system to allow for different pieces of the system to be worked on by different people. So just kind of, again, a broad level overview of how and why we're seeing so many enterprises move to multi-agent RAG architectures. Great. I think we are a little over time now. Victor, do you want to move to the next steps?
Absolutely. Absolutely. Let me just enable my video here. Okay. Next steps that I can recommend you with the size and potential of generative AI, you can find specialized expertise from the AWS partners, and one way to accelerate this is with partners that have that demonstrated expertise, experience, and of course the success stories that we are looking for to confirm that they've done this before, that they know what they are doing. And the generative AI competency partners, they have a unique advantage in driving these aspects. The AWS partners have they pass a rigorous validation that they do in conjunction with us to ensure that they are following AWS best practices, that they have that demonstrated technical expertise and the customer success. What else as part of the next steps and call to action? You can go to the AWS marketplace where you can explore and you can find multiple options, including several from SingleStore. And there's no more than to thank you so far about the time that you took for being with us. And Alex, if there's something else you want to say, but so far, thank you so much.
No, yeah. UT, I think we're ready to close.
All right. So thanks everyone for joining. This was such a nice session. We had so many questions, right? And really appreciate your time and energy that you attended the session. And thanks, Alex. Thanks, Victor, for attending. And I hope to do a webinar again soon with you. It was such a nice session. And I hope that next time we'll be able to take up more questions. So all right, so just a reminder that we have amazing sessions that are coming up, and we also have a raffle. You are able to still enter for anyone that joined late. I'll just put it in the chat again, and then like you can log in using the resources that you could utilize during today's session. Very sorry that we went a bit over time, and we are presenting a very amazing topic tomorrow as well. It's called Deploying AI-Driven Personalization Engines, and Alex is doing that webinar. So if you enjoyed today's webinar, please feel free to tune in tomorrow as well. So, all right. So Thanks everyone for joining. Have a great rest of the day. Take care, everyone. Bye-bye.
Thanks, everyone.
Thank you and goodbye. Have a
Bye.
great day.